All right, so today we are rewriting equations and formulas, okay? So notice I didn't say solving, okay? So we're not solving anything today. We're simply rewriting it, okay? All right, so what does that look like? Well, the first thing you need to know is some definitions. This will help you know how to rewrite equations. A literal equation has two or more variables. Why is this significant? Well, when an equation has more than one variable, you cannot solve it unless you have a value, okay? So when you see a literal equation, you're looking at it from a different perspective, all right? And I'll show you in a minute what I'm talking about. So to rewrite an equation, I'm going to solve for a certain part of the equation. And the problem will tell you specifically what you're solving for. If you're solving for, a certain variable, it will tell you. So what does that look like in example 1? All right. Now, on all 4 of these problems, I'm going to be solving for the same variable. So last class I had the question, well, Ms. Kinder, will I ever be asked to solve for X? Not in this scenario. And that'll make more sense when you learn a chapter later on in the year. Honestly, I think it's several chapters down the line, okay? But solving for y is actually a really important concept, all right? So for today, we're just learning how to get y by itself. We don't really understand the full y behind it yet, okay? So if I'm solving for y, I need to put my heart around the term that has y, okay? So that term is going to get solved for in my second step. The first thing I want to do is move what is not connected to y. And I do this by inverse operations. All right, so 2y plus 5x equals 6. How could I get positive 5x to cancel to the other side? What do you think? Subtract it, okay? So subtract 5x and subtract 5x. All right, you just want to minus it. So now it cancels on the side with y, which is what I wanted. Now here's the important, another important part about solving. 6 minus 5x is not like terms. I cannot combine them together. So that's a mistake that we see sometimes. Do not combine them together. All you're going to do now is bring it down. And my rule says that you bring down your x term first. Bring down your x term first. So because it was minus 5x, I bring down a negative 5x. All right? I cannot combine it with 6. Now, because 6 in my original problem was positive, that's why I have a plus 6 after the 5x. Okay? So this is a little different because in all the equations before, I would combine those terms, but I can't here because they're not like terms. All right, now one more step to solve to get y by itself. So does everyone agree that multiplication is connected to my y? Yes. Multiplication. So what's the opposite of multiplication? Division. Please leave your fraction a fraction. Don't change it to a decimal. Leave everything a fraction unless it reduces to a whole number. All right, so let's see how this reduces. My rule says I have to divide everything by the number connected to y. So y equals negative 5 over 2x plus 3. All right, now that doesn't mean a whole lot to you yet. All right, the only thing we're practicing is getting y by itself. However, in a chapter later on in your book, we actually take this equation and we will graph it on the coordinate plane. Okay, and I can look at this equation and I know exactly how to graph this line. All right, but that's something I'm going to teach you guys later on. All right, okay, so now let's look at the next problem. 12 equals 6x plus 3y. All right, so what am I solving for? Solving for y, okay? I see that it comes after the equal sign, so could I rewrite it so my y comes first? All right, so I'm going to say 6x plus 3y equals 12. Does everybody see what I did there? Okay? All right, put your heart where you think it goes. Go ahead and put your heart where you think it goes. Okay? All right, Cadence, where does your heart go?
3y.
Around the 3y. Very good. All right, and Hudson, how can I get 6x to cancel to the other side? Very good. Subtract it. So everybody agrees 6x minus 6x cancels. Now do the same thing to the other side. All right, Trey, can I do 12 minus 6x? Are those like terms? They are not. Okay, so now I have 3y equals, now look back to the problem we just did. Which term would I write next? Can someone raise your hand and tell me? Which term would I write next, Destiny? Negative 6x. All right. And again, you're just doing that because I told you. I'll explain more of why we do that later on. Okay. But just for now, just trust me on it. All right. Would it be plus 12 or minus 12? What do you guys think? Would it be plus 12 or minus 12? Plus 12. And then what's your question?
So for the last one, would you not simplify that?
On the last one, no. I want you, are you talking about the fraction?
Yeah.
I want you to leave it a fraction. Have you guys heard of slope? Rise over run? Have you heard of slope? Okay, so you just have to trust me then. This is my slope, and if I don't have it as a fraction, the negative 5 over 2, I don't have rise over run. Okay, so again, it doesn't make a lot of sense until I teach that. Leave it a fraction. Don't change it to a decimal. All right?
That's not it. Okay, so say you put that one in the fraction the next time, you leave all of them in the fractions?
Well, let me show you.
All right.
Yeah. If it reduces to a whole number, if it simplifies or if it reduces, you need to do that. But don't make it a decimal. Okay? All right. So, Elizabeth, what would I divide now the entire equation by? 3, because that's the value connected to y. Okay? So divide everything by 3 now and reduce it. If it reduces to a whole number, make it a whole number. But if it reduces and it's still a fraction, leave it a fraction. All right? So negative 6 divided by positive 3. What is that? Negative 2x. And then 12 divided by 3? Plus 4. Okay? Negative 2x plus 4. All right. Okay, next one. What?
That's what I was asking.
I know, but I said let me explain it.
She doesn't listen.
And then once I explain it, then it'll probably line up with your question, is what I meant. Okay, so here we go. Next one. All right. 4x minus 4y equals 1. Put your heart where around the term that you're solving for. Okay, so it says to solve for y, just like we just did. Did you guys put your heart? Okay, Daniel, where does my heart go? Okay, around the, not the 4y, but the negative 4y. Okay, we're getting real specific there. All right, now Michael, you all right there? Okay, I was about to call on you and I saw you grimacing. What do you need to do next to get y by itself?
We need to minus 4x on both sides.
Yes, very good. Minus 4x on both sides. All right. Now, Zoe, can I do 1 minus 4x? Are those like terms? 1 minus 4x? Can I do that? No, I cannot. Okay. So now let's bring everything down, right, Emily? Okay. So bring everything down. Negative 4y equals, Emily, what term would I write next after the equal sign?
Negative 4x.
Very good. Negative 4x. And Abby, all right, thank you, Emily. Plus 1. Abby, can you bring it home? What would you do last?
Divide everything by negative 4.
Yes, ma'am. Divide everything. Is that what you were thinking, Mikhail? By negative 4. Now, this is going to look a little different than the first two. When I reduce, okay, my negative 4s can cancel. All right? And then I have x. Now, look here, guys. I don't want two signs in the same fraction. So I have to figure out which sign needs to go in front of 1/4. What is positive 1 divided by negative 4? How many negatives do I have? 1. Okay, so it's negative 1/4. Okay, you see that? So you're dividing one negative, so it's a negative. Negative 1/4. Don't do plus a negative. We don't want a double sign there. Okay? All right, y equals x minus 1/4. All right, I'm going to leave you to it on the fourth one. I want you to try to solve for y completely, start to finish. When you have your answer, please compare your answer to your buddy next to you. And then we'll go over it. Okay, so heart goes around the 5y. Okay, how do I get negative x to the other side? Add x. Okay, add x to the other side. All right, now I have 5y equals, I would do a 1x. All right, it just helps me remember there's a 1 there. Plus 10. You guys didn't try to add those together, right? They're not like terms. Okay, now what do I divide the whole equation by? All right, divide by 5. So y equals 1/5 x plus 2. Now, I did see some people say x over 5 equals 2 or plus 2, and that's okay as well. But I do prefer the x to be next to the fraction. And again, that's just going to help you later on. All right. Now, this is the most important part of your lesson. Okay. Now, I am going to show you how this same idea or the same principle applies to formulas. Do you see any numbers here? Are there any numbers? No, you only have variables. So all we're doing is we're manipulating the formula. For example, if I asked you on the area of a rectangle, okay? If I said, I want you to solve for the base, okay? Solve for base. How would you do that? How could you rewrite this formula where the base is by itself on one side, okay? It all has to do with inverse operations. What operation is connected to the base? What operation? Multiplication, okay? So you must divide by whatever is connected to the variable you're solving for. In this case, b. Divide by h. So your answer, okay, once you cancel out your h, is b equals a, my big A, divided by h. Okay, what does this mean? To solve for the base, I would take my area and divide it by the height. That's all I'm doing, okay? So if I needed to solve for base and I knew my area and I knew my height, area divided by height gives me base. That's all I'm doing here, okay? So I want you to do the same thing now and solve for h. Do the second one. Do the same thing now and solve for h. All right, what do I divide both sides by to solve for h? B.
Oh my God.
Divide both sides by b. And h equals, so what does this mean? To solve for height, I take the area and I divide it by the base. That's all we're saying here. Okay? To manipulate a formula so I can solve for a certain part of it. That's all we're doing. All right? Okay, so now what if I had more than one term connected to the variable I'm trying to solve for? What do you guys think I'm going to do? Divide by both terms. Divide by r and t. Divide by r and t on both sides. So if I wanted to solve for, P stands for principal, it would be the interest divided by the rate times the time. And you're going to learn more about simple interest later on. Okay? Right now, all we are doing is manipulating the formula. Okay? All right, so now, hey, excuse me, rude. Okay? All right. If you're solving, it makes it a lot easier to solve the formula. Okay?
So we're in like solve.
All right, so what would you divide the next one by?
Oh, PT.
PT, right?
Oh my god.
Capital. You're solving for R. Okay? Some of y'all, never mind. Okay, R equals
What were you gonna say?
interest
What was you gonna say?
divided by principal times the time. If I wanted to find out the interest rate. All right? All we're doing is manipulating formulas. That's all you need to understand. Nope, we got one more thing. All right, so do you guys know, we're going to skip the challenge. Do you guys know Fahrenheit and Celsius?
What is
Okay, so Fahrenheit and Celsius, all right, are two different ways to measure temperature. All right? So, we need a formula for Celsius. Okay, so we already have that. To find the Celsius, I take 5/9 and I multiply that by my Fahrenheit temperature minus 32. Okay, so that's how I do Celsius. But what if I needed to solve for Fahrenheit? What if I needed F by itself? Okay, so I want you to rewrite the formula because I don't want to mess up my Celsius formula. C equals 5/9 times F minus 32.
We have to rewrite it, but it's already there.
You need to rewrite it because you need your Celsius formula. Okay? So now we're going to convert my Celsius formula to Fahrenheit. All right? And I do that by getting F by itself. All right? Now, before you think I have to distribute, which you could, but it's going to be a real pain to distribute 5/9 times negative 32. So before you do that, why don't we do 5/9 times 9/5? Okay? Reciprocal. So now they cross cancel. As long as I do the same thing to the other side, I'm okay. All right? So now I have 9/5 C equals F minus 32. All right, so think example 1 now. All right, what we needed to do. So how could I get F by itself? How could I get negative 32 to cancel to the other side? Add 32. Okay, but is 9/5 C plus 32, are those like terms?
No.
Just kind of go with my inflections there. No, they are not. Okay? So when I bring everything down, I say 9/5 C plus 32 equals F. All right? So now I have my Fahrenheit formula. All right? Can we write this forward with the F coming first?
Yes.
All right, let's read it together. F equals 9/5 C plus 32. Okay, so now I have a formula to convert to Celsius, and I have a formula to convert to Fahrenheit. Why is this important? Because I'm going to tell you, all right, I need to compare in the same unit. Let's look at this question. The average room temperature is considered to be 70 degrees Fahrenheit. Okay? The temperature outside is currently 23 degrees Celsius. Is the temperature outside greater than or less than the room temperature? So here's what you can't do. You can't say, oh, well, 23 is less than 70. Right? You can't do that because they're not what? They're not in the same unit. They're not the same measurement. So now you have to decide. You have two formulas to choose from. Do you want to convert Fahrenheit to Celsius or Celsius to Fahrenheit? Okay, usually that's a preference, right? Do we talk in terms of Celsius?
No.
Do I say, it is 48 degrees Celsius outside? No, we talk Fahrenheit, right? So I would convert Celsius to Fahrenheit, all right? Which means I need to use my formula for F. F equals, what was it? 9/5 C plus 32. You just wrote that formula. Okay? Y'all with me so far? So where do you think you're going to plug in 23 in this formula? In for C. Okay, plug in 23 for C. So F equals 9/5 times 23 over 1 plus 32. All right. Ugh. Anything I can cross reduce? No. That's a bummer. All right. So now I need to do 23 times 9. You might need to do it by hand. 23 times 9 is 207. So F equals 207 divided by 5 plus 32. Well, what do you think you need to do with this fraction? You've got to divide it. That doesn't make any... Okay, I can't say, well, the Fahrenheit is 207 divided by 5 plus 32. They're going to look at you like, is that supposed to tell me something? Yes. That's not telling me anything. You need to do the division. 207 divided by 5.
41.
Okay, 5 goes into 20 4 times. 5 goes into 7 1 time. 2 left over. Add your decimal. Bring it down. Okay, 5 goes into 20 4 times. So F equals 41.4 plus 32. Almost done. Deep breath.
We're not done?
Nope. Okay. All right. Figure out the Fahrenheit. This is the easiest part. What's 41.4 plus 32?
4.6.
Nope.
73.4.
73.4 degrees. This is not your answer.
Oh my God.
Go back now and answer the question. You got to answer the same question in that class in about a month. Okay? Go back to the original problem. You did all that work, guys, to compare Fahrenheit to Fahrenheit. Now answer the question. Is the temperature outside greater than or less than the room temperature? It's greater. But here's the problem. You can't just say, it's greater than, without showing any work at all. Okay? You can't just say, no, you get 0 credit because all you did was guess. Okay, outside is greater. Because outside it's 73.4 degrees and inside room temperature is 70. All right. If you understand that, that's everything you need to know for today's lesson.